Hi friends, welcome to Unit R Day 6. We're jumping into example 3. Simplify by using the product property. 26 is the square root of 50. So what I'm thinking about is okay, what do I have that's a perfect square that I can break out of 50? And I can break out the square root of 25 times 2. And then I can simplify this by taking the square root of 25 times the square root of 2. And the square root of 25 is 5. So simplifying this using the product property gives me 5 radical 2. Similarly, 5 times the cubed root of 125, if I think about this, I'm going to have 5 times, so the cubed root of 125, well, 125 is actually a perfect cube, so I'm going to keep that here with this part. I'm going to have x cubed, but then I also have an additional x here. So the reason why I'm doing that is those first two parts, that 125 and x cubed, is a perfect cube, and then I have this x that's left over, and I call that my leftovers. And when I think about what I'm going to do here is when I simplify or split this apart into its two parts, I'm going to have the cubed root of 125x cubed, but I'm also then going to take it times the cubed root x. And the way this works is now I can simplify, so I can take 5 times, and then the cubed root of 125x to the third is 5x, and then I'm left with that cubed root of x left over. So this is 25x times the cubed root of x. 25x times the cubed root of x. So that's 27. 28, I have negative 4 plus the square root of 20. The square root of 20 is the part that I can simplify here. So if I simplify that, the square root of 20, the square root of 20 is going to be plus, the square root of 4 times the square root of 5, because I can break up 4 and 5. That's all divided by 2. So I have negative 4 plus 2 square root of 5, all divided by 2. I'm showcasing this one specifically because that divided by 2, we can divide both of the terms by 2. Since you can divide negative 4 by 2 and the 2 radical 5 by 2, we can simplify this to be negative 2 plus the square root of 5. That's example 3. Example 4, simplify by using the quotient property. So this one we can actually combine to be under the same radical. So by doing that, we have the square root of 18a to the 5th over 2a. We can use our properties of exponents that we used in the previous section to divide that out. Now I have the square root of 9a to the 4th. If I take the square root of 9a to the 4th, I get 3a squared. Now, because I started with an even root, then I have an absolute value bar with the a squared as well. For 30, with the cubed root of 81 over 125x cubed, I'm actually going to go the other direction. I'm going to take the cubed root of each of these individually. Cubed root of 81 divided by the cubed root of 125x cubed. So the cubed root of 81 is not a perfect cube, but what I can do is I can break it down into a perfect cube. So the cubed root of 27 times the cubed root of 3 over, and then this is a perfect cube. This breaks down, cubed root of 125 is 5, cubed root of x cubed is x. Again, no absolute value because it's an odd root. Cubed root of 27 is in fact 3, so I have 3 times the cubed root of 3 over 5x. Then the next part, simplifying using rational exponents. So what I have here is I can simplify square root of 36 p to the 4th, q to the 5th. I can take each of these to the 1/2 power. So if I do that, let's see, I'm going to go ahead and convert 36 to 6 squared. So I have, 6 squared, p to the 4th, q to the 5th. And all of this is raised to the 1/2 power. So what I'm going to do is I'm raising each of these to the power to a power, so I multiply through. So this is going to be, so 6 squared raised to the 1/2 is 6 p squared, and then q to the 5 halves, q to the 5 halves. Again, so we have this part here, so we're going to have, we had an even root, so this is going to be the absolute value of p squared, the absolute value of q to the 5 halves as well. For here, v, so I have v cubed, and then v to the 4th, and then square root raised to the 1/2 power. Those are equivalent. So I'm left with v cubed times, and then this is going to be v squared. Now this v squared, we know is the absolute value, However, because what is happening here, because of that v squared, because we end up with that being a 2, we're going to have v to the 5th when we combine. So we combine through these. So when we have v to the 5th, we have that part here. This one, we have it kind of nested. It's a cubed root and then a square root. So if I think about what's happening here, is I have x to the 1/2, and then that's raised to the 1/3. If I think about that, if I have a power to a power, I'm multiplying it, so it's x to the 1/6, or the 6th root of x. Now for this next one, I have the cubed root of n and then the square root of n. So if I think about this in terms of exponents, I have n to the 1/3 times n to the 1/2. A lot of students try to do what we did here with this as well. This is not the same. We're multiplying the same exponents, so we can add them. So if we add m to the 1/3 plus 1/2, we need to get a common denominator, and what we end up with is m to the, equals m to the, what is that, 2/6? Yeah, 2/6 plus 3/6. So we get m to the 5/6, m to the 5/6 power. All right, join me in the next video where we talk about example number 6.